So, hello my dear students, I welcome to CBC. So, this is the lecture number 2 on this chemistry of this IIT JAM biotechnology syllabus. Okay, and particularly we will be discussing about periodicity in properties, periodic table, and how the properties of these elements varies in this periodic table. This is what we are looking into it right now. So, this is purely by following the syllabus that is given in your syllabus of this IIT JAM biotechnology. Okay, so I have yesterday shown you few things related to this periodicity in properties. Okay, let me continue that session. Yeah, so I just want to have a quick recap of yesterday's discussion. So tell me what we discussed. So tell me what we discussed in the last class once. Yeah, so what are the properties we discussed? One is atomic radius as well as ionic radius, right now, and the next we discussed about isoelectronic species also. This is not property, actually we discussed the concept. Okay, and then next we also discussed ionization energy or enthalpy. Okay, and we need to discuss about electron affinity or electron gain enthalpy as well as electronegativity. Okay, so I just wanted to give you one or two questions on this, then we'll move for the other topics. Okay, so based on the previous discussion, tell me how this atomic radius varies. How this atomic radius varies across the period. So from S block to P block, what happens? Decreases. Okay, this is decreases across the period. Okay, and what about down the group? Increases. Why it is increases? Yeah, the new incoming electron which is entering into the like that atom is coming into the new nth level. That shell number is getting increased right now. Like we are writing NS2 is the general electronic configuration for a particular group. For example, this is the electronic configuration for second group of elements like beryllium, magnesium, these things right now. So here we are writing 2s2, here we are writing 3s2. See, this n value is increasing now. It means if this is the nucleus of an atom, okay, and these are the shell numbers. So here I can write n equals to 1, n equals to 2, n equals to 3. See, as n values are increasing, the radius also becoming increased. So I can say down the group atomic radius increases. Okay, and even ionic radius also follows the same order. Okay, for example, ionic radius yesterday we discussed Li plus, Na plus, next K plus. If they ask what is your order? So maximum for potassium, same whatever the followed order explanation for atoms, ions also same thing here. Okay, now what I have discussed again, I have compared atom with respect to anion and also with respect to cation. So tell me what is its order of size? So more electron cloud, see, more negative charge means more electrons are there, so electron cloud is bigger, so size also bigger. So A minus like this. Okay, so now if I take any isoelectronic species, for example, we have considered yesterday, what we considered? We have considered Mg plus 2, Na plus, then next F minus, O minus 2, N minus 3. So tell me what is their order? So tell me how many electrons are there in this species first? What is the nitrogen atomic number? 7. Minus 3 means, see, if I write like this, its atomic number is 7, so 7 electrons are there. If I write minus 1, 1 electron is added, so 8 electrons. If I write 2, 2 electrons added, so total 9. If I write 3 minus 3, so total 10 electrons are there in this species now. Now similar to that, O minus 2 means 8 atomic number and 2 electrons added, so 10. Similarly fluoride, 9 atomic number, 1 electron added, 10. Like that, sodium atomic number 11, but positive charge means removed one electron, so it is also 10. Mg plus also Mg plus 2, 12 atomic number, removed 2, so it is also 10. So the species having same number of electrons are considered as isoelectronic species. Now they will ask us to arrange them based on their size. So tell me which is larger size? See, negative charge is there now. More negative charge, more electrons are there. See, if more electrons are there, their electron cloud is bigger. See, if this is a nucleus, if electrons are here, this is one shell number you can say, so this is shell number 2, like this. If number of electrons increasing, the shell or the electron cloud is becoming larger and larger, so radius what happens? Increases. So now electron cloud, see where we have electron cloud, more electron cloud, -3, so it should have larger size. Again, see how many protons are there in this? Just 7 protons. So positive charge is less, negative charge is more, it means electrons are more, so cloud will be expanded. But here protons are 12, means nuclear charge is more, but electrons are 10. So protons are more, electrons are less, means that protons will strongly attract that electron cloud, so that size becomes shrinks, small it becomes, so smaller size. So what is the order, like I given one relation yesterday's class, tell me what is that? Nuclear charge is inversely proportional to size. So more nuclear charge, more positive charge, lower is its size. Is that clear or not? Yeah, based on this you can give the order. I will show you one question also based on this now. Okay, so we will solve all the questions given in the IIT JAM from chemistry part. Next we need to discuss about ionization energy. Now tell me what is the basic understanding you have from the word ionization energy. In the short form I am writing IE. Sometimes it is also mentioned as IP, ionization potential. Okay, so whenever they are saying potential, units are electron volt per atom or per molecule they will mention, per mole they mention. Ionization energy generally they may give in like what is the energy units? Joules, calories, kilocalorie per mole, kilocalorie per atom or kilojoule per atom, like that they will mention. Okay, so now if I have an element A, we need to ionize it, right now. So ionizing means removing of one electron here, especially when we are talking about ionization energy, it means the minimum amount of energy required to remove an electron from neutral gaseous isolated atom. So I mean I should make it as A plus electron is removed. So atom, this should be in what state? And it should be isolated and it should be neutral. Okay, so if I remove electron from element A, atom A having in solid form, can I call it as ionization energy? No, we should definitely make it into gaseous state. So conversion of solid into gas, what we can call? Sublimation. What is that process? Okay, so that is different energy, that you can talk it as delta H sublimation, enthalpy of sublimation or energy of sublimation in the simple words I can say. Okay, so this is the energy we can call ionization energy. You should not take here as ionization energy directly. Is that clear or not? Yes. Okay, so if I remove one electron from this atom, it becomes unipositive ion. So this respective process I can call it as IE1, first ionization energy. If I remove electron from here, it becomes what? IE2, second ionization energies. So I can write A plus 2 plus 1 electron is removed. Okay, tell me whether it is exothermic or endothermic. Yesterday discussed. See, what do we mean by endothermic? We are supplying energy to pick out this electron. If this is an atom containing electron, in order to remove this electron we are supplying energy. So I can say delta H is positive, enthalpy is positive. So I can say endothermic process. Tell me which is greater, IE1 or IE2? IE2, because here it is becoming positive, electrons are strongly binded in this case. So removal of electron become difficult, so that we need to supply more amount of energy to remove that electron. So successive ionization energies if we compare, so IE, like last one, like IE3 is greater than IE2 greater than IE1. Can I write like this? And so on. Okay, this is also clear. Yeah. So these things we discussed in the last class, and I also shown you these things also, atomic radius. I made you to like do the questions also based on this atomic radius and all. Okay, next ionization we discussed. Now tell me what are the, this is what about ionization energy we discussed now. So now what are the factors affecting on ionization energies and how it will varies across the period down the group we need to know. See, first of all let us understand variation along the group. So look at this, if you compare the group elements, let us say first group elements only I am taking, lithium, sodium, potassium, rubidium, cesium, let us say. Okay, what is their general electronic configuration for this group? NS1. It means this is 2s1, 3s1, 4s1, 5s1, 6s1. I am not writing complete electronic configuration, valency I am using. Okay, so now if you look what is their numbers here, increasing, right? So it means if this is a nucleus, the shell number is getting increased. So now tell me which atom electron, valence electron is far from the nucleus? Cesium. Since it is far from the nucleus, it is easy to remove now. Yes or no? Because if it is close to the nucleus strongly bind this, the one which is closer, right now. It means which electron is required more energy to remove? Away from the nucleus. More energy I am saying, na? More energy means which is close, which is require less energy to remove away from the nucleus. So which is having lower ionization energy? So larger atom, lower ionization energy. The down the group atomic radius increases, size increases, so down the group ionization energy decreases. Okay, so what is the order of these ionization energies? Lithium is larger, sodium, potassium, rubidium, cesium. Is that clear or not? Yes. Okay, so due to this reason, having low ionization energies for these alkali metals when we compare with the other elements of periodic table, since they have low ionization energies, easily they will give their electron. We can use them in the photoelectric cells. Have you studied about photoelectric cells anywhere? Yeah, somewhere you have listened that. So we will be using rubidium, cesium, these elements as the applications in the photoelectric cells. Clear? Yeah. So down the group ionization energy what happens? Decreases. Yeah. So across the period you tell me now. So why it is increases? So yeah. So if we go like this in a period, for example second period elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So we know noble gases have fully filled electronic configuration. What is that? For this 2s2, 2p6. So these 8 electrons are there now, those are fully filled in the respective orbitals. Now that fully filled electronic configuration are highly stable. So if I remove one electron from here, that stable species become unstable. Therefore it has highly hinder or highly inert to give that electron. So it won't give electron easily. Therefore it requires highest energy to remove the electron. So which is having highest ionization energy respective period? Always noble gases in all those respective periods. Okay. After this, fluorine is having, what is its electronic configuration? 5. For this, for this 2p3. Now look at here, fluorine, if we give one electron, it becomes a stable electronic configuration like noble gases. Now it has more tendency to gain electron rather than losing an electron. Therefore it is also having highest ionization energy. It means more difficult to remove the electron from fluorine also when we compare with the oxygen. Now look at oxygen and nitrogen. See, nitrogen is having 2p3 electronic configuration. So how many p orbitals we have? 3. See, when I say shell, just now I have represented now atom means this is nucleus, around we have shells. So these shells are represented like 1, 2, 3 something like this. or I can also say K, L, M, N, something like this. Okay, in these shells again we have subshells. What I have? Subshells. Okay, that subshells are indicated like S subshell, P subshell, D subshell, F subshell, like this. Again in these subshells we have orbitals. What we have? Shells, subshells, orbitals. Okay, so now S subshell has one orbital. Okay, P subshell has 3 orbitals, like this, 3 we are writing. For D, 5 orbitals. How many orbitals are there? 5. For F, 7. Just use odd numbers. Okay, 1, 3, 5, 7. That's enough. Okay, so now if you look at this P has how many orbitals? 3. So 1 electron, 2nd electron, 3rd electron. Right now, so now see P orbital is half filled. Right now, either full fill or half fill containing species are there. Those configurations are highly stable. So therefore, the removal of electron from nitrogen is really difficult now, because if I remove here, the electronic configuration becomes unstable. So therefore, nitrogen won't give its electron. Okay, but if I remove from oxygen, it is relatively easier than this nitrogen. So out of nitrogen and oxygen, which is having more ionization energy? Nitrogen. You can write like this. Okay, so what is the order we got? Neon, fluorine, after that nitrogen, after that oxygen. Okay, then next carbon. Next, between this boron and beryllium we need to compare. Beryllium is having 2s2 configuration and boron having 2s2 2p1. So see, 2s2 means this s orbital, again this shapes, subshells I told now, they have respective shapes. For these spherical shape, for p orbital dumbbell shape, for d double dumbbell, like that we have. Okay, so now around the nucleus, which shape is more symmetric? Spherical. Right now it means this s orbital is more symmetric around the nucleus. It means whatever the electrons present in s will be more strongly binded to the nucleus. Therefore removal of electron is difficult from beryllium when we compare with the boron. So can I write it like this? Yes. Okay, this is like this, this is like this. Lithium having just 2s1 configuration, easily we can remove. So like this. Finally, what is the order? After oxygen, nitrogen, oxygen, next carbon, next beryllium, boron, lithium. Is that clear? The word or the statement you need to use here is what? Yesterday I told you, penetrating capacity. It means closeness of orbital towards the nucleus. The closeness of s orbital towards the nucleus is more when compared with the p, d, f. Okay, so that is what concept it is? PC. Okay, is that clear? And what about this abnormality? This is half filled electronic configuration. So I am writing HEC, half filled electronic configuration. Okay, you can make a note of it. Okay, after this, done with this, now tell me, apply same concept and tell me for third period elements fast. I want answer for this. How can you give for third period elements? What are the third period elements? Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Yes, tell me. Yes. After this, just look at their electronic configuration, that's fine. See here what I made, neon means here if I write argon, that will be greater. After that chlorine, after that oxygen or nitrogen, here also nitrogen, phosphorus. What is that? Phosphorus. So this is having a half filled configuration higher. Then between this, like this. Okay. Now tell me overall order. I mean some simplified order. Argon highest, chlorine, phosphorus, sulfur, silicon, magnesium, aluminum, sodium. Is that clear? Yeah. So these are the like ionization values you should orders you should remember. Okay. Now what is the general statements? What is the variation? If someone asks you generally, you give me in one line statements means ionization energy across the period increases. Fluorine, chlorine is having more when we compare with this side elements. Down the group decreases. These two lines you can remember. And there are some breaks across the period. Where are the breaks? Whenever it is having half field configuration and this penetrating capacity. These are the two factors affecting. Next, now see, again I am solving these questions just to make you more clear with the concept. Okay, since we have some time, I can do this question so that it makes more clear. See, the successive ionization energy values of an element are given like this. Okay, so see, successive, what we discussed, successive ionization energy values increases or decreases? Increases or decreases? Increases. See, values are more, it is becoming more and more now. So just we have seen element A becoming unipositive, becoming bipositive. This is IE1 I told you, IE2 I told you. So IE2 is greater than IE1. Did I discuss or not? So the successive ionization energy values are, see here, they are getting raised. Okay, but if you observe, first read the question what they are asking. Are given like this. We need to identify the element, which element having these ionization energies from out of this 4. Very easy. Look at here. First of all, if you want to do anything in chemistry, you need to know some elements, their atomic number and writing electronic configuration. So by looking at these 4, tell me their electronic configurations. Boron, atomic number 5, 1s2, 2s2, 2p1. Okay, next for this just tell me valency, 2s2, 2p2. Okay, for this 2s2, 2p4. So here what we have, helium gas configuration, like I can write 1s2 or just I can add atomic number 2 is for helium, I can write that. And here also helium I can write. For nitrogen also here I am writing helium 2. See, 2 electrons over, still atomic number is 7 means 2 over means 5 more required, 2s2, 2p3. Done up to here. Now look at their ionization energy values. So what you are observing here, first 3 ionization energy values are, they are rising, but they are relatively comparable. Comparable or not? See, 800 3 times increase, and here it is just 1000 times, like value increased by 1000. But if you go from here to here, there is a large difference. It means removal of first 3 electrons are relatively easier, but that 4th and 5th electron becoming difficult. So 4th electron is really becoming difficult, more energy is required. So it means in the valency of that particular atom, how many electrons are there? 3 electrons are there, that's why we are able to remove that first 3. Okay, that 4th electron might be in this noble gas configuration, like somewhere inside of this, like helium, something like this. Okay, that electron removal becomes difficult. Yes or no? So it means how many valence electrons are there here? 3. So tell me in which of these 4 elements valence electrons are 3? Look properly, you can look. Boron, see here only it has 3 valence electrons. So we can easily remove these 3, the 4th electron becoming very difficult as it is having helium gas configuration. So able to identify or not? So this is one of the very important concept. Okay, by looking at the ionization energy values, we can able to identify what? The element or the how many valence electrons present in that particular element. Okay, next, what about this? We discussed, same question we discussed. Tell me, all 4 are isoelectronic, all of them have 10 electrons. Next, see, can you match them? Do not scare by looking at the values in this electronic configuration. Just use some common sense and answer it. A, C will have more. That is fine. Now, in order to get more clarity, what element having this electronic configuration or which element having that electronic configuration? How many electrons are there? 7. So 7 means nitrogen. Here 5 means boron. Here 8 means oxygen. This one beryllium. Right now, tell me, did we written an order for second period elements or not? Yes, tell me that order. Highest is for neon. After that fluorine. After that, after next now now tell me, see what is the electronic configuration of beryllium? 2s2. For boron 2s2 2p1. So from where we can easily remove electron? This electron is easily removed now. So it has lower energy than beryllium. Is there any issue? No. Is that clear now? Yes. So this is the order we have taken. Now tell me, see, whatever your approach you have given, that is perfectly right, but if you directly go with that, you will get a wrong answer. Why? Because first of all, you know, this is the highest electronic configuration, like most stable electronic configuration, so that should have higher ionization energy. See, after this also you can compare with this. So nitrogen should have highest. Where is it? After that, so tell me oxygen. See, these should be oxygen right now. So but if you, whatever the statement if you given, if I follow that, you might be going with A as 3. Do not go like that. Just take the elements and compare if there is any confusion. Okay. So is that clear? Why B2, B3? After that, this one is for next. That's it. So can go with the option showing this A2, B3, C4, so D1. So option number 4. Okay. Next. So what are the important points here we need to mention here is, so if we go across the period like this, what happens to the ionization energy? Increases. If we go down the group, if I go diagonally, see, it is increasing, it is decreasing. So there, see, increasing, decreasing. So almost cancel out each other. So the elements which are placed diagonally may have similar ionization energy values. Is that clear or not? Yes. Next. So important points. What are the important points here? Ionization energy values increases with decreasing the size. Okay. Next. Ionization energy increases with increasing more nuclear charge, more positive charge, more is the ionization energy. Okay. Why? Because see, tell me, removing electron from A or A plus, from where it is difficult? So that's what you can understand from this in a simple way. Okay. Next, what I told you, ionization energies increases if the atom have half filled and filled orbitals. Next point, what I told you, the penetrating power of orbitals is in the order SPDF. That's what 2s2 having 2s2 having more ionization energy than 2s2 2p1, like beryllium and boron. Is that clear or not? Yeah. Done. Next, this is the other important topic that to be discussed. So what they are saying, electron gain enthalpy. So what is electron gain enthalpy? For example, previously we studied ionization energy. We made element A to respect to cation by removing one electron. Here, take element A and make respect to anion like this. So again, whatever the definition you have seen, similarly you have to take here. See, when an electron is added to neutral, see these lines are same, neutral gaseous isolated atom. Okay, here I have taken A, they are saying X, let us say X. Okay, X is an atom, this is neutral and gaseous isolated atom. Okay, by giving, see, to this to convert into respect to anion. So conversion of anion takes place by addition of one electron. See, addition of one electron, so anion is formed. Okay, so during this process energy may released or energy may absorbed. The enthalpy change accompanying the process is defined as so during this process energy may be released or energy may be absorbed. That energy is called enthalpy. Okay, is that clear? So now electron gain enthalpy, what is the use of electron gain enthalpy then? So it provides us ease with which an atom adds an electron to form anion. It means what? Ease means what? How much easily we can add one electron. For example, I am giving element A, B, C. So which element can easily gain one electron? Can be understood or can be given by looking at its electron gain enthalpy values. Here more electron gain enthalpy value, it means more negative the value it is, more easily it can accept the electron. What I told you? So more negative the value, more easily it can gain the it means when I add this electron to this atom, what it will do? Anion, and it may release some energy. So that release energy you should represent in the negative form. Okay, so it is releasing energy means what? It has more tendency to gain that electron. Okay, in some cases if it is already stable, if this element is already stable, if I add one electron, will it take? I am saying it is already stable, will it take if I add the electron? So now it won't take. It means we need to force that electron to taken by that atom, right now, that element. In this case we are supplying the energy. So in this case it becomes X minus here also, but energy is what now? Enthalpy is now positive. So here you can say endothermic, here you can say exothermic. Okay, so if electron gain enthalpy is positive means what you can say? It is not having any tendency, or it is having very low tendency to gain the electron. If it is having more negative electron gain enthalpy means it is having more tendency to gain the electron. This is the line you can remember. Now, okay, let me give you some questions. Yeah, so you can look at this. Here again sometimes they will give the word electron affinity. So electron affinity means also more negative electron gain enthalpy, more affinity it has. Okay, for example, if you look at this value which is having more negative value here, you can highlight this. Chlorine is having minus 349. So it means chlorine is having highest electron gain enthalpy value, highest negative electron gain enthalpy. It means it is having more tendency to gain the electron. So now they will ask you like this: arrange the following based on the tendency to gain the electron by giving some set of elements. Okay, if they give fluorine, chlorine, bromine, iodine, how do you write? Chlorine. If you look at the values, you will directly get the answer, but I will tell you the explanation for all that also. Chlorine, after that fluorine, after that bromine, and then next iodine. Sir, how do we get this order generally without remembering that value? No need of remembering the values, but just try to remember the orders I will give you. So what is this orders? See, you need to understand the factors affecting here. What are the factors affecting electron gain enthalpy? See, what I told you, electronic configuration. If it is already stable electronic configuration, so will they have tendency to gain the electron? No. See, that's why noble gases are having what? Positive. So positive indicates what? They have very less tendency, or they are not able to gain that electron. So electron affinity is not shown by these elements. Now if you see halogens, we know these are halogens, 17th groups. They required one electron, like they have ns2 np5 electronic configuration, right? So by gaining one electron becomes noble gas. So in order to gain that stability, they have tendency to gain electron easily, right now. So that's why these halogens in the respective periods will be having highest electron affinity. Okay, so now what are the factors? So first factor is their size, or simply I can say size and their nuclear charge. Okay, so smaller size, more tendency to gain the electron. Why smaller size? See, if the size is small, if this is the nucleus, if the size is small, see, now here one electron is there. Since the size is small, easily these nuclear forces can act on this electron and gain that electron, no? Yes or no? So small size, more tendency to gain the electron. So just keep it aside, observe these values. So down the group, what happens to the size? Size increases. So electron affinity or electron gain enthalpy decreases. So which is having more value now? Chlorine, more negative, more tendency. Okay. Now why I have closed this? This is smaller size, it means it should have more electron tendency, right now, but it is having lesser than the chlorine. There might be some other reason we need to know. Okay. So now as of now, up to here it is clear now. So you can see this order and this order also. Is that clear or not? Yeah. So now tell me what is their electron affinity or electron gain enthalpy order? Chlorine more than bromine more than iodine. Up to here it is clear. Okay. Now we need to compare chlorine and fluorine. Okay. So now look at this. Fluorine becomes by gaining electron fluoride ion. Chlorine becomes by gaining electron fluoride like chloride ion. So now if you look at its electronic configuration, it is 2s2 2p5. This is 3s2 3p5. By gaining electron it is becoming 3s2 3p 2p6. This is also becoming 3s2 3p6. See, if you properly look into it, fluorine and chlorine, which is having larger size? See, since it is smaller, this is larger size, that electron gained by the fluorine and chlorine will be stable in which case? The chloride ion is more stable when we compare with the fluoride ion. Why? Because since a smaller size, more electron density in this size. More electron, more like charges are close to each other. What happens? Repulsions. So repulsions are more in which case now? Fluorine, when we compare with the chloride ion. Small size make it to gain the electron, but after gaining the electron, what is the scenario in the fluorine? More repulsions, electronic repulsion. Therefore that makes it to be unstable. Therefore which is having more tendency now? Overall tendency is more for. Is that clear or not? Yes. So chlorine, after that fluorine, after that bromine, after that iodine. Is that clear or not? Yes. This is the order you can make, and one more for halogen, like this oxygen family. So now tell me, between oxygen and sulfur, which is having more? Sulfur. Okay. By looking at the values you are saying. See, whatever the concept, see, I told you chlorine is more than the fluorine. Here also apply same story. Fluorine, definitely sulfur will be more than the oxygen. Okay. So now the overall order of this oxygen family is something like this: sulfur, after that selenium, tellurium, polonium, and least is oxygen. So oxygen is least in the 16th group, fluorine is second in the halogen family. These two orders you can remember. Majorly they may ask from here only. Okay. Yes. So what are the groups having positive values? Second group elements and noble gases and this nitrogen. These are the three things having positive values. Okay. Remember that. Okay. And the next thing is, just solve these two questions. Is there any question here? Look at this, just tell me answer for this JAM question only, na? Tell me. Fast. Huh? first statement, second ionization energy larger than the first, that is true only na. IE1 is lesser than IE2 successive ionization energy, that is true. Next, atomic size increases top to bottom in a group, that is also true. Top to bottom what happens? Increases. Next, required to add electron, is that correct? Let us put aside, go for the next statement. Electronegativity of atom is the ability to attract the electron towards itself. It is correct only. We will discuss about this, about the electronegativity once again, because I haven't discussed electronegativity with you till now. Next, this is correct only, I will tell you. This statement, I told you some elements have more tendency to gain electron, that means it has positive, negative. If it is having no tendency or very so in that case what we need to provide the energy, so that is positive. So it can be positive or negative, but they told that electron affinity of an atom is the energy required to add. Is it required only? No, it can be released also. So this is the most incorrect one right now, so you can go with option number 3. Okay, hope it is clear. Electronegativity, we will see this, we will see this, yeah. So this is about the session, remaining we will discuss in the next session, okay, tomorrow or next session, okay. So thank you for watching for all the online students. I hope everything is clear. If anything to be discussed, write in the chat box, I will be looking into it and I will address that. Thank you.